Hi everyone, I'm Sindhuja Ravi. I'm going to do a presentation on MLAS. MLAS is nothing but machine learning in autonomous system. So here we'll be seeing about the principal component analysis used in autonomous systems. So generally what does a PCA do? So have you ever wondered why most of the movies are 2D even though the subjects are 3D? So usually this is because of the third dimension that doesn't usually add much to the story. So the camera will take the 3D information and flatten it to 2D without too much of the information. So PCA does the same thing but with the datasets. It takes a dataset with lot of dimension and flattens it to 2D or 3D so that we can look and make more sense of the data. So here you can see the movie John Wick movie versus the Avatar. So we know that these are the 3D movies, but then we get the movies in 2D pictures. So this is the same in real-time analysis of PCA. So for example, here I have taken the iris dataset, and the dataset includes three iris species with 50 observations for each species and no null values, and there are four features. So the four independent variables that are used from the iris dataset are sepal length, sepal width, petal length, and petal width. So all these variables are in centimeter. And the one dependent variable here is the class. And this is the data that is. So the coding starts from here. So here I have imported the libraries, uh, NumPy, Pandas, and Matplotting thing, and the scikit-learn. And for standardizing, we use a standard scaler, and for logistic regression, and then we use the training model and the test model, and also we import the PCA. And here in line number 17, we read the CSV data file, which has the iris dataset, and then we print the first 5 rows of the data frame, and uh, using iris data.head will do the same. Then we do the class replace thing, and the above line will replace the strings with numerical values for easy processing. Then we create a new data frame by dropping the column class from the iris dataset. And then we create a new data frame for column class. And then here we do the standard scaler where we take the standard deviation and then we fit the transform with the scaled x values. Then here we randomly shuffle the scaled x value and split the 80% into training subset and 20% into testing subset, and the random subset is 0 so that we can make some training and testing subset across different execution. Here in the above line where model is equal to logistic regression, we use one of the most used supervised learning classification algorithm, and the model we fit the testing model to the training subset. The accuracy here, the above line finds the accuracy by comparing the predicted value with the actual value, and then we print the same. So next we set the number of PCA components as 3 and fit the transform according to the scale PCA values. Randomly we shuffle the scaled x new values and split 80% into training subset and 20% into testing subset, and the random state is 0 so we can get the same training and testing subset across different executions. And in logistic regression, we take the solver as LBFGS and the multi-class as OVR, and then we fit the model to the training subset and predict the class for the testing subset. So again, we calculate the accuracy by comparing the predicted data with the actual label, and then we plot the first principal component, second principal component, and then see the graph. So here it's in 3D dimension, and we can see three clusters, and the accuracy for PCA after taking the number of components as 3 was 0.9, which is 90%. And when number of components is 2, like when we display the same with the components 2, so we get accuracy as 0.83. So here the accuracy has dropped because we can see at few places at the green and the yellow clusters has overlapped in few places, and that is why the accuracy has dropped from 90% to 83%. So here now we modify the code where we take PCA, the number of components as 1, and then we scale the PCA values using the fit transformation function and randomly shuffle the scale x new value and split 80% into training subset and 20% into testing subset, and the random state is 0 so that we can get same training and testing subset across different execution. And again we perform the logistic regression here, taking the solver and the multi-class thing, and then we fit the model to the training subset, and then we'll do a prediction of the class for the testing subset. And the above line will again calculate the accuracy by comparing the predicted data with the actual data, and we again plot the same graph and we see. So here we can see that before doing PCA, keeping number of components as 1, we can see that there are 3 clusters and the accuracy is also 90%. So yeah, so we can see that principal component analysis is very useful in segregating the data set where the important data sets can be taken and the others can be dropped. So this is one of the most important concept in machine learning. Thank you.
Hello everyone, I am Srikari Birbhotla, currently pursuing Master's degree in Computer Engineering at SJSU. The world of machine learning has been a fascinating journey, and today I am excited to share with you a project titled Kickstarter Success Rate Prediction, seamlessly blending technology with human creativity. Before we dive into the details, let's talk about why this project is significant. Kickstarter has become a bustling hub for creative minds and aspiring entrepreneurs. However, a great opportunity comes with a great challenge. Many projects face uncertainties in achieving success. That's where our project comes in, leveraging machine learning to predict success rates and provide valuable insights. The objective is to predict whether a Kickstarter project proposal will succeed or fail in achieving its fundraising goal based on launch information. This classification problem involves binary output, and input features encompass project category, funding goal, project duration, description, and number of backers. Before we dive into the methods which we are used to predict project success, let's take a look at the data set we'll be working with. Here we are using Kickstarter data with features.csv file, which has 20,632 rows and 60 columns, which includes the type of the project, project launching date, deadline of the project, country in which the project is being done, currency of that country, and so on. This diverse data will help us to train a robust model capable of generalizing to different project types. To carry out this project, we leveraged various predefined libraries such as NLTK, which is used for text preprocessing, Pandas for accessing data frames, NumPy for array operations, and Matplotlib for plotting graphs. The methodology we followed is structured here. The first step is data preprocessing. The next one is exploratory data analysis, and the last step is training and evaluation. And for that step, we selected logistic regression, decision tree classifier, and gradient boosting decision tree classifier. Data preprocessing stage, we replaced null values and created new feature to calculate the percentage of pledged over goal. Then we extracted date, time, hour, minute, month, and year from the deadline and created new features with them. We also dropped unrelated columns such as ID, photo, blurb, and so on, as that information is not useful for us and they do not contribute to the state feature, which is our target. And also, we performed text pre-processing. We used NLTK to remove stop words from the text and calculated the word count, character count, and average word length and appended these columns to the data frame. We also performed encoding to change the categorical column to the numerical. This step is very important as we cannot apply model to the text data. Instead, the data should be in the form of numericals. The next step is EDA. This is crucial step to better understand the relationship between the features and the project success. Used various visualization techniques to identify the relationships between the features. We also created a heat map to visualize the correlation between the features and project success. We also bar plotted state value counts, country percentile, currency percentile, which may be helpful for our machine learning model. A count plot for state feature is shown here with 5 features named as failed, cancelled, successful, live, and suspended. Count plot for currency percentile feature, which in which USD is in the top position. Count plot for country percentile feature can be seen here with US in the top position. And visualizing the distribution of pledged amount and funding goal, we used logarithm for better understanding so that we can transform the data to the normal distribution and make it easier to identify the patterns in the data. We then explored the distribution of goal and pledged values by state feature and also their relationships. The better view is a scatter plot with a regression line to visualize the relationship between the pledged and goal values. We can see the horizontal bar graphs here for the category feature in the terms of successful and failure. Here comes our new feature, which is percentage of pledged over goal. Here we can see that the success rate depends on pledged or goal parameter. Taking either the pledged or goal parameters alone cannot give complete picture, so we take the percentage of pledged and goal features. The date distribution in terms of pledged and goal can be seen here. The Baker's count in terms of logarithmic is also shown. After performing these steps, the data set has become reduced with the features of 43, which are more important in predicting the success rate of a Kickstarter project. With the final data set, we divided the data set into the training set with 70% and test set with 30%, and then started giving the train set to the models which we picked up already and started testing on that data. The logistic regression, it is a classification algorithm which was utilized in our project. Using the fit method, the model learned patterns from the training data. L2 regularization prevented the overfitting, and the evaluation matrix demonstrated an accuracy of 92.03%. Decision tree classifier, it employed the batch predict for efficient probability predictions in manageable batches. Hyperparameter tuning optimized the performance with metrics indicating an accuracy of 97.96%. The gradient boosting decision tree classifier and ensemble technique combined trees for improved performance. Hyperparameter tuning with cross-validation and grid search resulted in an accuracy of 98.17%. In conclusion, our project showcases the effectiveness of machine learning in predicting Kickstarter project success. The gradient boosting classifier emerged as the top by providing the valuable insights for project creators and potential backers. These findings contribute to the growing intersection of technology and crowdfunding, fostering a more informed and successful Kickstarter community. Thank you.
Hello everyone, my name is Saujanya Bhimani. I am currently pursuing my Master of Science in Computer Engineering at San Jose State University. Let's quickly dive into our topic, cloud computing. Cloud computing is rapidly transforming how organizations access and manage computing resources. In the next few minutes, I will provide an overview of what cloud computing is, its different models, benefits, and challenges. So, why cloud computing? Let's think about starting a new company. Initially, resources are limited. As you plan to set up IT infrastructure, you realize that significant investments are needed for servers, hardware, networking, electricity, cooling, data center space, etc. This complex setup takes months too. Instead, we can leverage the cloud. This saves time and money by renting these resources from cloud providers rather than owning them ourselves. We can start small and easily scale up and down based on demand. Coming to on premise, the on premise model requires significant upfront investment in hardware, software licenses, data center infrastructure, and skilled staff to install and manage it all. Ongoing operating expenses like electricity, real estate, maintenance, etc., further drive up costs. Capacity is constrained to what the equipment allows. Scaling requires lengthy procurement and provisioning cycles to deploy additional physical servers and storage. The downtime risks are also higher. Lack of agility around making IT changes, limited accessibility imposing collaboration hurdles, considerable time setting up hardware and software components. all weigh down teams. Whereas cloud coming to cloud computing, the cloud services are purchased on demand, allowing businesses to launch initiatives quicker without sunk infrastructure costs using flexible pay as you go billing that scales seamlessly based on real usage. Automation and self service access drive faster implementation measured in minutes or hours versus weeks or months. Built in resilience from redundant data centers, connectivity facilitating global teamwork, up to date technology with no disrupt upgrades. Cloud disrupts traditional approaches using shared, easily available resources. The cloud value proposition resonates with enterprises, making it rapidly expanding $500 billion market. Adoption is clearly accelerating as organizations recognize how cloud enables them to become leaner, faster, and more innovative. What is cloud computing? Cloud computing means storing data and running applications using remote servers on the internet instead of on premise infrastructure. You don't manage anything locally. With internet connectivity, you can access these resources from anywhere. Coming to the objectives of cloud computing, the key aspects are on demand access, network availability, resource pooling that enables sharing between organizations, elasticity to quickly scale, and usage based billing, only paying for what you utilize. Coming to the benefits of cloud, multiple drivers make cloud adoption compelling. Businesses can provision resources in minutes to respond faster to needs, reduce upfront infrastructure costs significantly, easily scale capacity on demand, and enhance security around sensitive data. Coming to the cloud providers, leading technology vendors like Amazon AWS, Microsoft Azure, IBM Cloud, Google Cloud Platform, and Oracle Cloud compete by offering platform services, tools, and global infrastructure to power cloud solutions. Coming to the cloud architecture, a typical cloud setup has three sections: a front end portal for users to access the cloud environment, a backend with servers and data storage, and a network to connect them. This is managed by the cloud provider. Coming to the big concept, it has five essential characteristics: three deployment models and three service models. Cloud computing characteristics are on demand self service, resource pooling, measured service, broad network access, and rapid elasticity. Coming to the types of cloud computing, it has the three deployment models and three service models. The deployment models, namely public cloud, private cloud, and hybrid cloud. Public cloud. The public cloud infrastructure is hosted by third party cloud service providers like AWS, Microsoft Azure, or Google Cloud Platform. It allows the general public open access over the internet to leverage these shared computing resources on demand via self service interfaces on a pay as you go billing model without having to set up any hardware on premise. Public cloud offers immense flexibility and agility to deploy workloads as services accessible from anywhere without upfront capital investments. The responsibility of managing the underlying cloud infrastructure is of the provider. This is a cost efficient option for spiky workloads. Coming to private cloud, in contrast to the public cloud, private cloud infrastructure is provisioned exclusively for a single organization's internal use. It may physically exist on the company's on premise data centers or be hosted externally with a vendor. Private cloud gives organizations higher control, security, privacy, and ensures compliance as owners operate the cloud infrastructure. Private cloud implementations allow leveraging cloud capabilities around automation, self service, and orchestration for internal stakeholders. Coming to the hybrid cloud, as the name suggests, hybrid cloud combines private and public cloud models, enabling businesses to tap benefits of both. Organizations can extend core backend infrastructure with public cloud services for things like websites, proof of concepts, temporary overflow capacity, etc., without migration complexity. More broadly, a hybrid approach balances agility and control for flexibility workload deployments across environments. In simpler terms, you can call a public cloud as a bus accessible to everyone, and a private cloud as one's own car owned by a single person, and a hybrid cloud as a taxi where we can rent it. Coming to the service models, there are three different service models, namely infrastructure as a service, platform as a service, and software as a service model. Coming to infrastructure as a service, it offers essential compute, storage, and networking infrastructure that organizations can leverage on demand without needing to purchase and maintain hardware. Examples of infrastructure as a service services are virtual machines, servers, networking, operating systems that power workloads. Leading providers are Amazon AWS, Microsoft Azure, Google Cloud, Google Compute Engine. Typical users of infrastructure as a service are IT administrators who are in charge of infrastructure operations. Coming to platform as a service, this is the next layer up. PaaS provides complete development and deployment platforms for building, deploying, and managing cloud based software without the need to set up underlying infrastructure. This allows faster application development. Examples of platform as a service are development tools, database management, analytics engines, container services that enable coding applications. Prominent PaaS providers are Salesforce Heroku, AWS Elastic Beanstalk, and Microsoft Azure. Typical PaaS users are software developers. Coming to software as a service, this is the top layer which offers complete end user applications accessible over internet rather than needing any installation locally. This eliminates infrastructure complexity for the businesses. Examples of SaaS applications are email, collaboration tools, ERP, CRM delivered as subscriptions. Leading SaaS vendors are Salesforce, Cisco WebEx, Concur. Typical SaaS users are functional teams consuming these applications. The increasing level of abstraction from infrastructure as a service to software as a service allows organizations to focus less on technology nuances and more on application functionality. Each layer builds on the capabilities below. Let's quickly summarize the service models. Infrastructure as a service provides basic building blocks of computing infrastructure. It has the highest flexibility but requires IT skills to administer infrastructure before deploying software. Platform as a service, it provides ready application development and deployment platforms with pre configured programming languages, tools, workflows. Abstracts AV infrastructure management, so developers focus on coding applications. Coming to software as a service, it provides complete end user applications that are managed and run on cloud infrastructure. Highest abstraction away from underlying technology complexities. So, to summarize, the responsibility for organization decreases as you move from infrastructure as a service to software as a service, while the abstraction layer is increase. So, we have to weigh trade offs between control versus convenience when choosing between self service infrastructure, deployment platforms, or turnkey applications as services. Coming to the pros and cons of cloud computing. Cloud computing provides organizations several benefits, including increased agility, lower upfront capital costs, scalable infrastructure, and availability of latest technology. However, dependence on internet connectivity, potential lock in to specific platforms, lack of customization control, and concerns around security of data in public cloud present notable challenges. Despite some risks requiring evaluation, accelerating adoption of cloud computing confirms enables companies to innovate rapidly at lower total cost of ownership. Who uses cloud computing? So, Pinterest uses AWS cloud to easily scale to serve over 250 billion pins to users globally. It allows them flexibility to manage spikes during special events. Cloud also helps them analyze data to understand user preferences. Spotify migrated to Google Cloud Platform to leverage scalable infrastructure for storage and streaming. This provides unlimited capacity to store and stream audio content reliably to millions of users. Netflix relies on AWS Cloud for most operations. Cloud provides vast on demand resources to run data pipelines, machine learning models, media encoding, etc. This allows faster innovation in personalization and recommendations. Overall, we can see that media and entertainment for content production and delivery, retail for e commerce and logistics, healthcare for medical imaging and records, manufacturing for IoT and supply chain, finance for risk analysis, software companies to accelerate releases. These are the industries actively transforming systems to cloud for scale, cost, and innovation. Coming to the conclusion, cloud computing represents a fundamental shift in how computing power is accessed like a utility, allowing organizations to innovatively leverage storage, bandwidth, and processing capabilities on demand. While the cloud model promotes business agility, scalability, and potential cost reduction benefits through resource pooling, security and compliance risks can deter adoption. With an expected market size approaching nearly $1 trillion by 2030, cloud is compelling businesses to balance the trade offs between disruptive opportunities and safeguards for successful modernization. Thank you.
Hello everyone, I'm Prashansa Evangeline. Today I'm going to talk about the project that I've worked on, that is online hotel booking application. I'm thrilled to introduce you to my project SkyStay, where luxury meets technology, redefining the way we experience hotel. My commitment is simple: to ensure excellence from the first step to the final stay. SkyStay's core functionalities include easy scheduling with transparent room availability, peak season highlights and discounts. The efficient hotel search allows users to find perfect accommodation based on location, price, and amenities. Stay offers a favorites features with notifications for exclusive deals and services post booking, empowering users to make informed decisions. Guests can At SkyStay, we prioritize security with robust multi-factor authentication, encrypted and secure storage, ensuring your peace of mind. Platform boasts an intuitive UI/UX accessible on multiple devices, featuring guided workflows for tasks like booking and canceling reservations. Performance is at the core, ensuring fast response times, supporting up to 10,000 users simultaneously with database queries executing in under 50 milliseconds, and for an impressive 99.9% uptime for consistent user access. The architecture comprises three layers: the client layer, representing user interfaces like web or mobile apps, and API gateway, which facilitates communication. The application layer manages core business logic through microservices like user, hotel, payment review, and notification services. This layer interacts with data layer, infrastructure layer, external components layer, security measures layer, and CI/CD tools for efficient and deployment. This comprehensive structure ensures a robust, scalable, and secure application ecosystem. This is the data. This is the flow chart. The process commences with logging in or signing up, branching based on their status. If identified as a regular user, they proceed to the hotel, allowing administrators to manage hotel listings reservations made by users. Regular users initiate their journey by searching for hotels based on their criteria. Following this, they can view detailed information about the listed hotels, choose a room, and define its availability. If the room is available, the process advances to the payment phase, where users make the necessary transaction. Post payment, users receive a booking confirmation, and the system seamlessly integrates, pursue feedback and reviews, read about other experiences, and contribute their own post-stay reviews. This comprehensive process concludes with the overall enhancement of user engagement and satisfaction. This Now let's talk about the technology that powers SkyStay, GraphQL. Its precise fetching single endpoint contribute to a seamless experience relationship handling make it a robust foundation for the project. Few code snippets that we have implemented in the project. The first one defines a Spring Bean for a password encoder using bcrypt, which is a hashing function that's secure for storing passwords. The second one handles the registration of new user accounts. It checks if the email already exists, creates a new user object, encodes the password using the previously defined bcrypt password encoder, and saves the user configuration that sets up an authentication provider. This is the MongoDB Atlas interface, which is a cloud database service. It displays a database with 4 collections: bookings, hotels, rooms, and users. The interface provides an overview of each collection, including the number of documents and data sites, which indicates the application is for managing a hotel booking system. For a hotel, it includes fields like image, name, description, and manager, with the manager being referenced to the user schema. The rooms field is an array of references to the room schema, indicating a one-to-many relationship between hotels and rooms. The schema is part of Node.js application for managing hotel data. This is a similar booking schema, and this is a room schema, and this is the user schema. This is the login page of the website where user has to log in with the email and password. If the user is new to the page, they have to access the registration page, give all the requested details to register into the web. This is the home page where the user needs to provide the input and enter the hotel name or location which they want to travel to, the check-in and check-out date, and the number of guests. As home, bookings, edit account, and logout options. The search hotel page where this is what you get when you search for the hotels, the hotel names, and this shows the price, the occupancy, and the date it has been added on. And this is the booking details page. This is the booking confirmation page. This is the hotel booking page. Coming up, the key achievements is that the project successfully handled data scaling, prioritized security for trust and reliability, simplified transactions with seamless payments, adopted a modular design for flexibility and growth, and ensured API connectivity for integration and expansion. Thank you.